Hi everybody, miss me? I know you did. But we gotta get back at it just a little bit while we're trying to deal with all that outside world stuff. So let's get back to math a little bit. But before we get started, okay, this is Distance Learning 2.0, lesson 8.2.1 or 8-21. And I wanted you to know I'm not just sitting here and doing math all the time. I did have fun with my friend Pong here. We went out, hit the town, relaxed, did a little sports, all that kind of good stuff. So hope you're doing the same when you get some free time. And of course, it wouldn't be the same without one of my dad jokes. So what is the best thing about Switzerland? I don't know, but its flag is a big plus. I know you were waiting for that one, especially Bella, I know, loves these things. And of course, there's Emma, but you know, Emma's a critic in that, so I'm not really sure there. But was that okay for you, Emma? Okay, let's move on. So what we're gonna do is we're actually gonna, for our first two lessons for Tuesday and then for Thursday, we're gonna do a little review for us, okay? Because we've been off for a week and wanna make sure that we have all this down pat. So you're gonna look, we're gonna go through this. I'm gonna give you a few problems to do. You'll figure those out, figure out what the answers are. And then I'll have a couple formatives that I will eventually post for you. But let's get started on this one. So 821, our first one was 836. Is 3 to the 5th power the same as 3 times 5? And if you remember, okay, 3 to the 5th power was 3 times 3 times 3 times 3 times 3. And the question is that equal to 3 times 5? And I think as you're doing it along with me, if we set this up, okay, and it actually might have been Elise who actually figured this out. 3 times 3 was 9. Times 3 was 27, times 3 was 81, and then this was 243, and we know those two aren't equal. Okay, so a little refresher. Then we jumped up to visualizing this. So how would I expand 20 to the 12th power times 20 to the 51st power? And as you were going through this, you were supposed to go, wait a minute, I had 12 of those, and I had 51 of those. So how many did I have total? So our problem should look like this. 20 to the 12th power times 20 to the 51st power. And if we're doing all these out, which I'm not gonna do all of them, so it's gonna look like this. Okay, you were supposed to be adding all those together. So 20 to the 63rd power. Okay, so when our base was the same, we were adding the exponents. Okay, so a good little refresher. Then we asked you to do this one. Write the expression 5 squared times x to the 4th times 5x in factored form. Got to make sure you read directions so you're doing it in the right form. So in this case, we have 5 times 5 times x times x times x times x times 5 times x. Then from here we're going, okay, how many 5s did I have? Which is 3 of them. Okay, and how many x's did I have? Which is 5 of them. But they want it in factored form. So this is not in factored form. This is what they were looking for, factored out. If we simplified it, we would go down to that form. Which brings us to the simplified exponent form of this next one. So we have 3w to the 3rd. So we have 3 times w times w times w. We have another 3w to the 2nd times 3 times w times w. We have a 3w times 3 times w times 3. So the question is going, we have what, 1, 2, 3, 4 3s. So we have 3 to the 4th power. And we have 1, 2, 3, 4, 5, 6 w's, or w to the 6th power. Now, we could take it another step further. Even though they wanted an exponent form, you could do 3 to the 4th power, which is 3 times 3 is 9 times 3, which didn't we just do this one? Which is 27, okay, which is then 81. So if we took it a step further, we have 81 w to the 6th power. Does that make sense? So again, this should be a little bit of review. That's why I'm going pretty quick on this. Okay, so then if we took it to this one, we talked about scientific notation. This is where we actually bring the x back for our multiplication in scientific notation, okay, instead of using the dot. And if you remember, scientific notation requires one factor is the power of 10, and the other factor is a number, it's got to be greater than 1, but it's got to be less than 10. So for example, 2.56 times 10 to the 5th, that's good. 25.6 times 10 to the 4th, no bueno, because that's not between 1 and 10. So our job is here, and we'll bring that up, is to put these in scientific notation form. So we've got to turn this to a number between 1 and 10. Well, let's move the decimal over once. So we have 2.56. But the problem is then that changes my exponent. Okay, now the question you guys had to figure out is, does this change to a 5? Or does it change to a 3? And you guys, hopefully, when you were doing this, if you checked your answer, you went 25.6 times 10 to the 4th. That means there's 4 zeros. So you did 2 point this, and you went 1, 2, 3, 4. If we do this one, okay, to the 5th power, 1, 2, and then we move it over 3 more, you would find out that it'd be equivalent to that one. I hope that makes sense. So then this one, we don't have it in exponent form. So even though we have the 5.6, we also are using a dot, which we shouldn't be using, times, and then instead of 100, we have 10 to the second. And then if we have this one, okay, we're going to move it over once, so we have 9.3 times 10 to the, is it 9th? Or is it 7th? So if you guys are curious, hi, up close and personal. So when we're doing this problem, okay, we're on 42 and 43. So if you go into yours on the 42 and 43, it has it all laid out there for you. Now the problem is I haven't heard from any of you. So I still need an answer on this one and on this one. Are we going the right way? So think about that for a second. I'm going to step out. And back in. So we already proved this one, because we did this and then we did this and it came out. The question is if you did this problem to the 8th power, moved over 8 times, then you did this to the 9th power, they come out to be the same. Hopefully you're saying no. Okay, so when we're dealing with something, okay, that is less than 1, when we move it over, I hope you got 10.93 times 10 to the 7th. So if we move this over 7 times, and we move that over 8 times, those two should come out to be the same. Questions? Okay, let's move this then. Now you've got to do these. We've got to write these in scientific notation. Remember, your decimal's always here. So we know we're going to have times 10 to the something. Move it over, 1, 2, 3, 4, 5, 6, 7, 8. That tells me I moved it over 8 places. My decimal's now there, so I have 3.7 times 10 to the 8th. Here, and again, it helps to keep track of it. If you need to move it along, I know I'm going to have times 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. My decimal's now there, so it's 1.2345, You've got to keep all of that along with it. And then finally we have this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 4.871. Questions? Okay. So now I want you to do 47, 53, and 54. So do those on your own right now. Pause the video. Once you're done with them and you've shown all your work, you can come back to the video And on the next slide, which I'm about to show you, are the answers. So again, you don't want to jump up to the answers. Do them first on your own. Make sure you've got this down. And then we have the answers there for you so you can check them. Thanks again. Great seeing you guys. We're going to see you again. Talk to you later. Bye.